I'm going to show you how we made a secure battery-operated GPS tracker using the Meadow. We used EasyEDA to make our own custom PCBs. Once we had created a Meadow as a component, it's easy to make new boards for any purpose. This we have made freely available in the component library. Just search for Meadow. All you need to do is draw up your circuit, lay out the components on the board, and send to the factory. Around 24 hours later, they will ship for as little as $5. Here I am adding a GPS receiver, OLED display, and this signed at source secure processor. This chip provides an API of cryptographic security functions around an internally generated key which cannot be extracted. Data you sign with this chip can only ever have come from this chip. It also provides the very best accelerated hashing functions and a true random number generator. At TFA Labs we predominantly use Linux for our R&D and production services. In-house we use MonoDevelop as an IDE, and given that we write our own add-ins, we took to writing one for the Meadow as well, leveraging work already carried out by Wilderness Labs. So if I plug my new Meadow device into my PC, it appears in its own console window at the bottom of the screen. Additional Meadows will also appear, and you can select between them when you deploy your app. At the top of the console there is a menu bar, details about the device itself, and radio buttons to enable or disable your app when the device boots. Here we're looking at the file manager, where you can add or remove files from Meadow's flash manually. You can also download the latest Meadow OS and flash it from here. So let's deploy an application. We'll test the sign at source chip first and make sure it's functioning. First we will query the firmware version. Then we will request the public key. Remember, it's impossible to read the private key. We will request 10 bytes of true random data. And then we will ask the signed at source chip to sign the random data with its private key. We click on Run, which starts the deployment. The Meadow is first rebooted and switches off any previous deployment. It has reconnected, its file system is checked, any missing files are uploaded now, just our application in this case. Then another reboot, the Meadow reconnects and shortly it will start our application. Running. Firmware version, public ID, true random number generator, and the signed random number. If you were to give a third party these three bits of information, public ID, the data you're signing, and the signature, they could independently verify its authenticity. GPS modules typically output NMEA data from their serial ports. You can either parse this data yourself or look for a library. I'm creating a new application using the Meadow template. NuGet is the package manager for .NET, and NuGet Explorer is built into MonoDevelop. There are thousands of packages available, many of which run on the Meadow without modification. Sure enough, we can find a library for NMEA parsing. Once we have parsed the data, we need to send it somewhere. For this I'm going to choose a decentralized data network called Streamer. Streamer allows you to publish your data privately or publicly to any number of subscribers. You can even sell your data streams in their marketplace. We need to go into NuGet again to pull in the Streamer.NET library. We need a message class which we can serialize into JSON. We then create an account on Streamer and create a new stream. Give it a name and a description. A stream ID is provided. We need to code this into our Meadow app. We add in our JSON fields. The signing field is not required as it can be included as part of the protocol message. Built into Streamer is the canvas, where you can interact with your data in real time. We first want to find the stream, then add in a map, and then link up the fields. You can do things like add conditional functions and send messages, even execute smart contracts on the Ethereum network. You might want to make a payment, for example, based on a completed journey or receipt of a RFID tag. At TFA Labs, we back decentralized services such as Streamer, but only with hardware signatures and strong encryption. The nice thing about the Meadow with our signed at source chip is you can give the developers one level of access, but the data itself is tamper-proof, what we call trustless. If there are no keys to lose, there is no need to reprogram all your IoT devices in the field after a suspected security breach. These are some of the security measures our high-profile clients are demanding. We can go a step further by writing the data to a public or private blockchain. This gives you further proof that the data was created at a point in time without the possibility of history being rewritten.